Hey, welcome back everybody. We're going to take a look at exercise 44, which is the first, I think, homework exercise of this particular lesson, which starts with quite a difficult one, I would say. So if you have trouble with this one, I think that is quite understandable. Let's take a look. In triangle ABC, angle A is 30 degrees and AB is 7. At A, they ask, is it possible to draw ABC if BC is 3 centimeters? Well, we must first then draw what we know. So we know that AB is 7 centimeters, so let's say A is here, 1, 2, 3, 4, 5, 6, 7, then B is here. Connect the two. You guys, of course, use your protractor triangle. I use my tool for a second. And it's given that angle A is 30 degrees. Okay, we've practiced this, right? Put the 0 on here. I'm going to align it like this, so that's if I now draw 30 degrees, which is right here, not here, because then the angle will be obtuse. I now see would, if it is drawable, be somewhere on this line. Again, draw it here, not down here, because then you'll get triangle ACB instead of ABC. It's also given that given you're going to investigate whether it's possible if BC is 3 centimeters. In that case, I should take my pair of compasses and make the distance 3 centimeters. So measure out 3 grids here. 1, 2, 3. And as you can see right here, if I would draw this, you'll see that this semicircle doesn't intersect with my leg anywhere, and that means in this case this is a triangle that cannot exist. There is no triangle where AB is 7 degrees, angle A is 7 centimeters, sorry, angle A is 30 degrees, and BC is 3 centimeters. That's not possible. So is it possible? No, not possible. Okay. Then at B they say, well, there are 2 possible ABC triangles if BC is 4 centimeters. Draw both of them. Okay, if you say so, that means that if that is possible, I want 2 different configurations, 2, 4, 6, 7. I call this one A, call this one B. Now I'm going to be very lazy and do a copy paste trick and try to copy paste it to here. Great. I want this one on the grids though, like this. Okay, let's take a look. Angle A is still 30 degrees, so that means we start the same way as we did before, right? So 30 right here, and let's draw the angle, something like that. Maybe make it even a bit longer so I know I have enough space, and let's do it like that. And now that I'm actually thinking about it, I could even be more lazy. Move this up a bit and do it like this. Oh, this way you see, children, why you shouldn't be lazy and stuff stops working. Let's see, like this. Okay. Now they say BC is 4 centimeters. So what I should do now is take my pair of compasses and measure out 4 centimeters. And you see something funny happening here. This is what they meant with that there were 2 possibilities. If I now draw the semicircle, you see that it is going to be here and here where it intersects, right? Here as well. It would be here and here. Of course, the same drawing, so that shouldn't surprise you. And those are the 2 possibilities. So apparently there are 2 triangles that here I could draw. The first one, I would connect them like this, right? Like that. And that means that then triangle ABC would look like this. And for the other one, I would connect them like that. And then the triangle ABC would be like this. Okay. Both have AB is 7 centimeter, angle A is 30 degrees, and BC is 4 centimeters, either that way or that way. And now then at C, they say you can choose the length of BC, that there is only one possible ABC triangle. Find out what the shortest possible length of BC is in that case. Okay. Once again, I'm going to be quite lazy and copy this part of the drawing that I could use. For you guys, that's going to be maybe a bit more difficult, but alas, sometimes that's the advantage. So we start like this. Of course, we don't know this here, right? This is not something we're going to use for this exercise. This is AB is 7 with angle A is 30 degrees. Let's say there's only one possibility. If that's the case, then you will see that I still put my pair of compasses here. Let's just take a look. Let's take a look at, if I make it this random length here, you see that in that case it intersects in two different places. So there's not only one possible option. Some people would say, yeah, well, let's make it very big, like this. And if I do that, and then would draw it, then it would miss out on here, right? So that means there's only one possibility, which would be here, because this leg has infinite length, right? Remember, I've only drawn part of it. This would, of course, normally continue on like that. And then you have one intersection point. But there's one thing that we in that case forget, that is find out what the shortest possible length is in that case. And there are still infinite options, because this one and this one and this one also all work, because I get bigger, so here I'm going to miss out on an intersection part in this part. But there is one more interesting one, and that is, if I'm going to get a bit smaller here, you'll see that what I'm doing here is I find a circle that intersects this twice. But if I make the circle a bit smaller, I can try to make it so that it just barely touches that leg here. And if that happens, that means that I only have one intersection point, which means I only have one possible triangle. And that would be right if I draw it. Let's do it in a different color so you guys, oh, not that one in a different color, this one in a different color. And it would be right. That's still black. Red, please. That would be right. Oh, now I'm going to move that. Thank you, drawing program. No red for today? No, no red for today. Okay, doesn't matter. You see, if I draw it like this, I really only have one option as well. Later on in mathematics, we will observe this point and we call this a tangent point, een raakpunt. En dan noemen we de lijn de raaklijn, the tangent line. That's only going to be important in 3rd grade and up. Mainly in 4th grade and up, actually. But this is an actual option here. And the funny thing is that if you would draw this triangle like this, again, this thing here is really messing my drawing. I have to take a look at the settings of my drawing program. If I draw it like this, again, I'm not going to go too much in detail, but you will see that this angle is in that case always 90 degrees. That's a property of a tangent line. Again, very interesting, but not the main topic for today. We're going to take a look at what the shortest possible length is. So what we still should do is now take out my pair of compasses and measure this, and I find that it's approximately a bit more accurate like this. In that case, BC will be, I think, around 3.5 centimeter. I think that's what the answer book will give as well. Maybe it will give 3.4 or 3.6, but I think 3.5 is what they want. And that's the shortest possible length that you can actually find. Okay. Very interesting exercises actually. Quite different from most of the exercises you'll see in the homework. So don't be anxious if you find this one difficult. Just continue with the other exercises and you'll see that then it's more focused on just simply drawing triangles. But I think it's also good to observe situations like this where you have to investigate a bit more. Okay, bye bye.